a new refrigeration system, and it's using the condenser out of the air conditioner that I turned into a heat pump. It's very high flow rate. The fan is very powerful, and that cools the discharge down really well. So I'll switch it on just now. This is using the SC21F compressor, and it's just R290 I've got in it just now. It's not the hydrocarbon blend. It seems to work fine with just propane on its own. And so what we've got here is the discharge coming out, and then it's coming back from the condenser into the filter dryer, and then it just goes into a capillary tube. And this capillary tube is just basically setting a temperature of, I think it's roughly -10. I'm not sure exactly, but I can, if I restrict this needle valve even more, I could get even lower temperatures. It's fully open just now, but as you can see, ice starts to form in that coil really quickly. It's very powerful, and it does move a heck of a lot of heat. So if I restrict that, eventually you'll see all the frost disappearing off it. But to get the water down to temperature, I just have it fully open so it can move the maximum amount of heat. And the air coming out, it is fairly warm. It blows very fast. I think it moves a heck of a lot more air than a standard condenser fan, which is just like the fan blades with the motor on the back. This is a centrifugal blower, so it's pretty high volume. With this system, I've no worries about closing this valve completely because the condenser is large enough to hold the entire refrigerant charge. And it could cool the evaporator down into vacuum. Half frozen up already. I have noticed at times the capillary tube sometimes shakes about quite a bit. That's because it's just got so much refrigerant flowing through it. I'm pretty sure it's 1mm capillary tube. It could be 1.2, can't remember exactly. But for this 3/4 of a horsepower compressor, you need quite a large diameter capillary tube to get the same sort of temperatures as you would with a much smaller compressor like the one over there. So now it's starting to freeze up right back to the compressor, and the problem with this system is the evaporator is really too small. It's made of 8mm copper tubing, same as the condenser, but it's really not long enough. I reckon I need about 15 metres, and I reckon there's only 6 on it just now. Plus if I had 15 metres, I'd be able to cool this water down a lot quicker. But then again, with making the evaporator larger, you eventually get to the point where the condenser cannot hold the entire refrigerant charge, so you need to put an accumulator on it. But if I was to make it longer, then I'll be able to efficiently chill down antifreeze, because I've got a project in mind maybe where I could just do a crazy project, a one-day thing where I could liquid cool my computer, really overclock it while running -20 antifreeze through it. But then you've got the issue of protecting against condensation inside, because the whole thing will just get covered in condensation and it'll just fail if you don't lacquer the circuit boards. So I've restricted it a bit more, and it's getting pretty cold. It's not freezing, but quite all the way to the compressor. It's I'll just be because there's not as much refrigerant in the evaporator, I just can't get all the way to the compressor now that I've restricted that. But it's really freezing that water really well. I don't think it'll be able to freeze the entire bucket, and that's because the evaporator really is just too small, and once water starts to freeze it, I don't think it conducts heat as well, and then you just end up where the system starts getting really inefficient because it's just freezing back to the compressor. So it'd really be better to chill down antifreeze, but I've only got about 4 litres of it. Need to get more.